Okay, this video will be over section 4.3 and at the end 4.4 logarithms. Okay, to solve equations we use inverses. If you have 2x minus 8, the inverse of multiplication is division. If you have x minus 5 equals 9, you're going to move the 5 by using the inverse of that, which is addition. Now we need an inverse for an equation like 5 to the x is equal to 8, exponential equations, and that's what logarithms are. They're inverses of exponents. So if you have 5 to the x equals 8, you rewrite it into a different format. The number 5 is your base, so it goes below where the g is. Then what was normally your answer is 8, so it comes next, and then your equal sign and your x. And what happens is it takes the power, which is x, and it rewrites it as, in this case, a logarithm between comparing two numbers. Now the easiest way to do this is you start with a base, go across the equal sign, and then come back to the exponent. Or start with a base, 5, go across to x, and then 8, so it's 5 to the x equals 8. It's always going counterclockwise. You have a base to a power equals your answer, or log, your base goes down at the bottom, answer is equal to your power. Now, just for some practice, if you have 3 to the x equals 7, if you want to rewrite that, 3 is your base, cross to 7, x. So it's log base 3, 7 of x. Okay, this is 2 to the w equals 6. 4, 16x, so it's log base 4, 16 equals x. This will be 3 to the 5th is equal to x. Now there's some properties. Anytime you have log base a of 1, you're going to get 0, because a to the 0 is equal to 1. Anytime you have these two the same, they're going to essentially cancel out, because you're going to have a to some power is a to the x, so they'll cancel out. And so you get x, whatever the power is. Okay, if you have log x is equal to log y, you can essentially cancel out the LOGs. It's not division. You would have to rewrite these with exponents, but anytime you have two equations where most of them are equal, then the other parts must also be equal. And then if you have a to a power, if this a matches that a, they again will cancel and you get b left over. Now some definitions. Base 10 logarithm is the log, that's on your calculator. That's a base 10 logarithm. Okay, we don't just write the 10. Now ln is also on your calculator. That is a base e, where e is that 2.71828, Euler's number there. Okay, suppose you want to find out what log base 2 of 8 is. If you rewrite that as a power, okay, the number 8 is 2 to the 3rd power. So you just change your 8 to 2 to the 3rd. Then these are the same, so that has to equal 3. Okay, 256, if you make that a power, it's 4 to the 4th. These 4s are the same, so you have the 4th power. Okay, 1/25 is 5 to the negative 2, because it's a fraction, making a negative power, and it's squared. So then these cancel, negative 2. And again, these are the same, so they cancel, and you get the number 9. Okay, solving. We can also solve equations x rewrite to the 2nd equals 25. And if x squared is 25, then x is equal to plus or minus 5. 2 to the 5th is equal to x. And so x is equal to 2 to the 5th, which is 32. 3 to the x equals 1 over 20, or square root of 27. Now we need our bases the same. The square root of 27 is 3 to the 3 halves. A square root is a half power. 27 is a cube. These are the same, so you get x is equal to 3 halves. Okay, if you're going to graph logarithms, there's a generic logarithmic graph, just like there is all others. It's the inverse of an exponential graph. Okay, if your exponential graphs went up, so a logarithm, that's your exponential. Your logarithmic graph is going to hit over 1 up 0, and it's going to curve up that way. Now it has a vertical asymptote at 0. It has a domain starting at 0 to infinity, and a range of up and down, negative infinity, positive infinity. Okay, suppose you have log base 3 of x minus 2. Okay, we can use our same old minus means go right. It normally crosses here, go right 2 units, so it jumps over there, and then you can draw your curve. So the process for transformational graphing is the same. Now if you look at this graph, it has a vertical asymptote, in this case of 2. Your domain starts at 2 and goes right. Your range is up and down, so it's everything. Negative infinity to positive infinity. Okay, suppose you have this one. Okay, plus 1 is left 1, plus 3 is right up 3. So we start here, go left 1, up 3, and then we're going to draw in our curve. Looks like that. Vertical asymptote and domain and range, you can find the vertical asymptote is negative 1. Your domain, negative 1 to infinity, and your range goes up and down, which is plus or minus infinity. Now there's some properties that you need to memorize. Anytime you have log base A of b, you can take log of b divided by log of a, or ln of b divided by ln of a. It doesn't matter. I frequently use ln because it's just less letters. But anytime you have a and b and you want to change bases, you can do that. So suppose you want to find log base 3 of 8. There's no key in your calculator for that, so what you do is do log of 8 divided by log of 3. You simply type that in your calculator, push the log key 8, make sure you close parentheses, divided by log 3. I believe it's 1892, or 1.892. Okay, the product rules, if you're multiplying, it turns into 2 LOGs. 1 LOG turns into 2. If you're dividing, it turns into 2 with subtraction. Multiplication is addition. And then powers. If you have a power, the power gets to jump in front of the LOG. So x to the y turns out to be y LOG, then x, and the y just jumps in front. Okay, suppose you have 5x. You can turn that into log of 5 and log of x added together. 7 divided by 3 is going to be log of 7 minus log of 3. This division turns into subtraction. 5 to the third, the power comes out. It's 3 log 5, or ln in this case. Okay, we can get more complicated. We have a 4 times x cubed divided by y squared. It's going to be 4. Multiplication is plus. The power moves in front. Okay, the y squared's on the bottom, so you subtract. The power moves in front. Okay, 3 square root of x, 5w cubed. It's going to be ln 3. A square root is a 1/2 power x. We're dividing, so it's minus ln 5. We're dividing by our w. It's on the bottom, so it's 3 ln w. Okay, we can condense using the same process. You're going to have 5. Minus turns into division, 3. Plus turns into multiplication, and the power jumps up. So it's going to be 5. X cubed, because this is positive, jumps up. And then the minus 1 goes on the bottom. Okay, section 4 is using a calculator. It goes fairly quickly. You just type these in the calculator. Push in the LOG 22.3. Push the LN key 4.8. Push the LOG key of 61 divided by the LOG key of 9. You have to split that one up because there's no log base 9. And then ln of e to the 6, you can just type that in and get 6. And then they have some word problems in there. If this represents the number of years since 1900, what's the percentage for 1995? Well, we're just going to plug that in. Put 1995 in there, type it in, it just gives you a number, in this case 71%. So that's everything that section.